Okay, can you put your screen on, kiddo? Maybe he's not there. Maybe he's waiting for me. Okay. So whenever you have an argumentative essay, we know that credible expert points of view help us, it's a stronger argument when it comes from someone who's an expert. For example, a forensic pathologist at a crime scene. We can trust their judgment, right? So whenever you argue an essay, ethos is very, very effective in a court of law. If the expert testifies, we trust them. The other one is obviously statistics, and that's factual information. So that's logos. Today, I'm going to use one on you that works in a court of law. It's called pathos. It's an emotional appeal. And it doesn't work on every essay because every essay doesn't lend itself to that. This one does. Because how can I argue against nuclear energy if I don't scare you? If I don't put fear in you? Nuclear energy uses uranium-235, which is massive amounts of radiation through nuclear fission, and nuclear fission creates more radiation. Great. If you can contain it, it can promote industrial energy when it works safely. So I'm going to use pathos today. So the video I'm about to show you just for a couple of minutes, it's going to connect with you emotionally. Okay, so I'm going to share my screen. Pull this over. And let me go back to the very beginning, because look at that. That's not creepy enough, right, everybody? Do you see the creep factor we're going to go to today? Here we go. All right.
Nuclear technology doesn't get great publicity.
It's the biggest online class I've had in I don't know how long.
In blockbuster films, it creates terrifying monsters such as Godzilla and the Hulk. It's characterized by incompetence in cult TV shows like The Simpsons and the hit HBO series Chernobyl.
What did you do? I did what you said. I switched.
Look at it! And it's normally in the news because something has gone wrong.
It's an atomic fire and the Soviets can't contain it.
The third explosion at the Fukushima power plant. Japanese Prime Minister says radioactive levels around the plant are high.
But nuclear energy is safe, reasonably reliable, and efficient. Without it, it'll be much harder to fight climate change. So why does nuclear power still only make up 10% of global electricity generation?
The natural power of the universe is harnessed in the new atomic bomb. Its tremendous possibilities are explained.
In 1945, nuclear's full, unimaginable power was demonstrated to the world. 8 years later, President Eisenhower proposed using nuclear energy as a way to redeem humankind for having brought such an awful technology into existence.
The United States knows that peaceful power from atomic energy is no dream of the future.
Oh,
That capability
okay,
already is here. Now, today.
When the nuclear reactors first opened,
I love his sideburns.
I
I don't know what that
there's
is.
a big futuristic
Weird.
buzz about them. This is when jet planes are new, nuclear reactors are new. We're just short of the age of the satellite. So this is very much a symbol of modernity. And it's also a symbol,
Modernity.
in some eyes, of peace.
In 1956, the world's first commercial nuclear power station was opened in Britain. By the end of the 1960s, 78 reactors had been built across 14 countries.
Like right there when you wear that hazmat suit.
Nuclear reactors generate power through nuclear fission, a process where uranium atoms are split and release energy. In the center of an atom is its nucleus, which contains protons and neutrons. In the process of nuclear fission, one of these nuclei breaks apart, producing smaller nuclei some neutrons, and some energy. If one of the neutrons hits another nucleus, it too will break apart in what is known as a chain reaction. To ensure the chain reaction takes place at the right speed and the power plant doesn't overheat, control rods made of neutron-absorbing materials are lowered into the reactor. In most reactors, they sit in water, which acts as a moderator, slowing down the neutrons and helping control the rate of the reaction. The energy from the chain reaction produces a huge amount of heat, which most reactors use to turn water into steam.
Nuclear power plants are basically very large kettles. They take water and they heat it up,
Kettle.
and then the heated water,
Like a
the
tea
steam,
kettle.
can drive turbines. And that's kind of what a coal power plant or a gas power plant does too. But nuclear does it very efficiently, and it does it with far less fuel because uranium has an awful lot of energy in it, whereas coal and gas have comparatively little. So you can fuel a nuclear reactor with, tons of fuel
A
rather
lot
than
of times they're
thousands of
built
tons of
on the
fuel.
water because they use water.
It's like an invisible force, isn't it?
What happens if there is an accident? We've got no chance.
And if it's uncontrollable, it's going to cause some harm, isn't it?
So what damaged nuclear power's reputation?
Okay, so we're gonna stop there with the creepy part. So do you want me to go creepy first or creepy at the end? You want me to scare you first or scare you at the end? Your choice. Nora, we're gonna let you choose. End?
End.
All right. Okay, so just to review, because I have to make the assumption not everyone's done the proponent side. Around the world, we use predominantly fossil fuels to promote energy. For example, we drill, mine, and burn coal, which is the worst. Oil, we like oil is the biggest probably fossil fuel. Oil is turned into petroleum for gas, propane, plastics, paint. So the biggest sector responsible for greenhouse gas emissions is transportation sector, which uses gas. So the last one is oil, gas, methane gas, or natural gas. So coal, gas, and oil are fossil fuels. When we drill, mine, or burn them, they release carbon emissions, CO2, into the atmosphere. That causes greenhouse gas emissions, which destroys a layer of our atmosphere. And the reason we have global warming and climate change is because we, globally, not just America, every country is destroying our planet. Okay. So if you go to your lead, you'll notice that I started with the 2015 UN Climate Change Conference in Paris, France. Okay, so we've known about this since 2015. The superpowers around the world, including the United States, Russia, Japan, China, Paris, France, your superpowers, signed an agreement, the Paris Treaty, the goal being to hold the increase in the global average temperature to above 2 degrees Celsius above industrial levels, to limit the temperature increase to 1.5 degrees Celsius above pre-industrial levels. This is in response to the world, not just the United States, the world's climate change emergency. If the 1.5 degree threshold is crossed, the United Nations Intergovernmental Panel on Climate Change warned it will unleash severe climate change impacts, including more frequent severe droughts, heat waves, and rainfall. According to NASA, the severity of effects caused by climate change will depend on the path of future human activities. So if we keep using fossil fuels and burning them to meet our energy needs, to meet the electricity in my classroom, on your computer right now, you need electricity that comes mostly from fossil fuels. So we as humans don't want to change our behavior. But the way that we can enjoy all the things we enjoy to live our lives requires fossil fuels, right? So here is the proponent side that we talked about last week. The only way we can stop these greenhouse gas emissions from increasing, and by the way, our use of CO2, our use of energy, we're going the wrong direction. It's 2024. This is 11 years, 9 years after this treaty. Our CO2 emissions are rising. They're not reducing. So that's why we're having this conversation this month about this topic. There are those who believe nuclear energy is the way to go. That if we don't do something drastic, we are going to destroy our planet. And I think you already see it. Last summer, did you know that we had 18 days over 105 degrees in Texas? Did y'all know that? That was a record. Never happened before. These are situations that we're going to see more and more often. The more greenhouse gas emissions, the more climate extremes and damaging effects across our planet. So nuclear energy is proposed as fast, effective, with very few carbon emissions. And proponents argue we're at a point where we don't have a choice, right? Okay, but here's the other argument. What about renewable energy? What about wind? You've probably seen wind turbines, okay? And if you were in my proponents class, we talked about that. Great, but wind turbines require wind. So yeah, they give us some energy, but it's not reliable, okay? Hydro requires water. What if we're in a drought? What if we didn't get enough rainfall? Okay, again, not reliable. And then the last one is solar. What do you need for solar? The sun. That's not 24/7, is it? Right? Okay, so renewable energy sources are great, but they're not enough to solve our energy demands. The argument for nuclear energy is it can do the rest. So now I'm going to argue against it. So what's the problem with nuclear power? Your first page kind of tells you what's going on. There's a small group of scientists that have proposed replacing 100% of the world's fossil fuel power plants with nuclear reactors as a way to solve climate change. Many others propose nuclear grow to satisfy up to 20% of all our energy, not just electricity needs. They advocate that nuclear is clean, carbon-free power, free source of power. Nothing is zero carbon, by the way, everybody. They don't look at the human impacts of these scenarios. Here I go. I'm arguing against it. Nuclear power plant, one nuclear power plant on average takes 14 and a half years to build. And most of them are in the 20-year range. Okay, how much do you think it costs? We're talking millions, right? And then let's talk about if there's a delay, right? So according to the World Health Organization, 7.1 million people die from air pollution each year, with more than 90% of these deaths from energy-related combustion. So switching out our energy system to nuclear would result in 93 million people dying as we wait for the nuclear power plants to be built. Okay, and let's say you have an existing nuclear power plant that you have to update. If anybody's ever updated an old home, it's a huge job. Like it's almost easier to build new. So the first argument is the lag time between planning and operation, the time it takes to get a nuclear power plant operational. So let me ask you this. You're seeing climate change. You're seeing it. You're seeing probably tornadoes. You're seeing, if you watch the news at all, obviously you're seeing extreme temperatures. Denver, by the way, 6 inches of snow yesterday, everybody. It's April 20th, right? And more forecasted today. So you're seeing extremes like, and we really saw it this past winter. Okay, so for example, I've given you one example after another on your outline. The Olkiluoto reactor in Finland was proposed to the Finnish cabinet in 2000 to be added to an existing nuclear power plant. Its latest estimate completion date was 2020. A PTO from plan to operation time was 20 years. What could happen to our global climate crisis in 20 years? Do we have 20 years? So that's argument number one. Number two is cost. And that's on page 2 of this first article. The levelized cost of energy for a nuclear plant just in 2018 was 151 million per watt hour. And that's cost for the energy and cost of storage. If you compare that to wind, 43 million per watt hour. You compare that to solar, it's 41 million per watt hour. So it's 3 times the cost, right? Not to mention, here's a really interesting thing, 20 years to build a nuclear power plant. To build a solar, the wind turbines is about 6 years. Solar, 6 months. Do you see the build time is quite different, right? So in 20 years, we could put all our energy into renewable energy and get more benefit than we get nothing in 20 years. Let me see if there's anything else I want to go over there. So meltdown cost. Okay. The last one's really interesting. Don't know if you know this, but if you saw the rods that were in the, the water for the nuclear fission process, those rods have to be replaced and they are contaminated with radiation. So where do you store radioactive waste that lasts for 300,000 years? You can't dump it in a landfill. You can't dump it in the sea, right? Look what you would do. If you know anything about radioactive toxicity, if you are exposed to a toxic level of radiation, you are dead in hours. It will melt your organs from the inside out. Your skin will slough off. I know this because I did Hiroshima and Nagasaki. Those that were in the blast, their skin just wiped off. The heat, the radiation, the level of energy is not sustainable to the human body. Okay, well, what if you're just, you get a little bit? Let's say there's a nuclear spill and you are unaware of it because radiation, by the way, you don't know if you're exposed. There's no alarm. There's no noise. It's like the wind. You don't know if you're even exposed. And would the government tell you? Right? So it costs money to store nuclear waste. Millions of dollars to store nuclear waste. So let me give you, and I'm just going to go to the outline for this one. In 2018, the combined cost for France, Germany, and the United States, just 2019, I'm sorry, just to store nuclear waste. For France, $34 billion, just in 2019. For Germany, $19.8 billion. For the United States, $96 billion, according to the World Nuclear Waste Report. So that's just to store nuclear, not even to build a power plant. Okay, so while the costs associated with nuclear energy continue to rise, maybe the smarter solution is to invest in renewable energy sources. Fascinating here. So besides the exorbitant cost to build a nuclear power plant, the cost to maintain them, to store hazardous waste, right? It makes little sense when there are renewable energy options, right? That we should invest in otherwise. Okay, that was the nice one. Here we go. So this one's going to be body 2, and you're going to have to scroll down. And I'm going to kind of go back and forth here, but it's at the very end. History's 6 worst nuclear disasters. And I'm going to kind of go back and forth here. So if you can't follow me, that's okay. I will tell you, everything is in the articles that I have painstakingly found to provide the best arguments for you. Nuclear energy utilizes nuclear fission, manipulating dangerous uranium-235, creating radioactive energy. Okay, that's dangerous and risky. And if it works, ladies and gentlemen, it's incredible. Okay, but who's going to work in a power plant? Are those going to be the physicists that create the process? Are your parents going to be willing to work in a power plant who are educated? The people who work in a power plant are your essential workers. They could make mistakes, and they often do. About 1.5% of all nuclear power reactors previously built around the world have resulted in a nuclear meltdown to some degree. Okay, I'm going to go really fast here. The worst disaster in human history was at Chernobyl. If you get Netflix, there's a documentary and there's a series. It's phenomenal. There's also one on Netflix for 3 Mile Island. I'm not going to go over that one today. And that was in Pittsburgh, Pennsylvania. I will just tell you the one in Pittsburgh. Our government told everybody it was safe. There's radiation in the air. People have responses to the radiation, and the government says it's safe. Are you going to trust the government when it says you're safe? So Chernobyl, built in the late 1970s, 65 miles north of Kyiv in Ukraine, was owned by Russia. One of the largest and oldest nuclear power plants in the world, having 4 reactors. Okay. A bungled experiment on one of the reactors created a sudden power surge that blasted the 1,000-ton steel top off the reactor. A lethal cloud of radioactive material gathered over the town of Pripyat, which was not evacuated until 36 hours later, before wafting over large parts of Europe. And Russia lied. The United States says, did you have a nuclear meltdown? We can see it from space. They're like, oh, yeah, I guess we did. Sorry. They did contain it, but I want to share with you what Germany, who's close by, says. This is what Germany says about Chernobyl. So basically, if you were in Chernobyl, you're dead. You're dead pretty quickly. The firemen that were called to the scene, all of them dead. It's a horrible death. The town of Pripyat, most of them have radiation-induced cancers. That's what it does. It does that. Here's what Germany nearby said. Radioactive particles drifted across the German landscape. Sandboxes were nicknamed death boxes. Contamination turned up in meat, vegetables, fruits, and foodstuffs all over the country. Frightened parents didn't know what to feed their children. Experts estimated hundreds of thousands of people on the continent eventually developed Chernobyl-related cancers. Okay. The second one I want to tell you is Fukushima. That happened in 2011. It's not even Japan's fault. There was a 9.1 magnitude undersea earthquake. Like you can't plan that. So during the emergency, there are 3 operational nuclear reactors were shut down successfully, but a tsunami hit after the earthquake. So the backup power and cooling systems failed. Residual heat caused fuel rods in all 3 reactors to partially melt down. And then reactors 1 and 3 exploded, and then reactor 2 exploded. So the worst thing about Fukushima, combined total radiation exposure from all 3 reactors remains unknown. Get this. Contaminated radioactive water generated during the accident is currently being stored and disposed of in the sea. They're disposing radioactive water in our seas. Now, the cleanup costs from Fukushima alone are trillions of dollars. The International Atomic Agency supported Japan's decision to dump water from this tragedy into the sea. They explained the concentrations of radiation pose no risk to animals or humans. Do you believe that? Even though they say it goes through a removal process, can you really remove radioactive waste? So the last one, and this one will scare you the most, is what's going on currently in Zaporizhzhia, Ukraine. So Zaporizhzhia is a nuclear power plant located in the Ukraine. It was captured by the Russians during the war, the present war. They weaponized the power plant in the war against Ukraine. The site has 6 nuclear reactors, is one of the largest in Europe, and has transformed Russia. It's a really genius military move. They have transformed that power plant into a military base. It's genius. Is Ukraine going to fire on it? No. Targeting the power plant not only placed Russia in an advantageous position, it gave them power to set off a nuclear explosion should they lose the fight, which they're still in right now. The International Atomic Energy Agency warned there's a real risk of nuclear disaster. They believe Russia who had taken nuclear engineers at the plant hostage could sabotage the plant, blaming Ukraine for any nuclear fallout. So this present day power plant scenario at Zaporizhzhia could set up future acts of terrorism from other nations who, while at war, could copy Russia's military strategy and attack other nuclear reactor sites. Were you aware that Russia was doing this as we speak? Do you trust Vladimir Putin? Okay. So clearly, whether it's radioactive contamination of the air, water, or food resources, the detrimental impact to animal populations or human lives can be adversely affected by nuclear power plant leaks or explosions. So the second body is really just the best one if you're going to do one body paragraph. And Viomini, when you start this class, you choose one body paragraph only. I do not want a lead. I do not want a conclusion. I do not want two. You will not be able to do it. It's too much. Choose one body paragraph and do it well. Nora, are you doing two? Okay. Pratush, how many are you doing? Okay. So when school is out this summer, up your game. And Venkat, are you doing one or two? Okay. So it's time. Y'all have been in the class. Raise it up a little bit because I've got a bunch of new people coming in. They're doing one. If you've been in the class a while, you need to challenge yourself and do two. Okay. All right. And Viomini, if you have any questions, follow the outline just like you normally do. Anything I've quoted on the outline, or go back in and find that information for yourself, but use the outline pretty closely. Okay. All right. So much more advanced topic. Yes. Questions? Yeah, Nora.
So no lead and no conclusion?
Okay. That's a really good question. Here's my answer. I have kids that do it anyway, and they are progressing faster than anybody else. If you challenge yourself to do more, right, and you've been in the class a while and know what to do, then you're going to benefit. But I understand that you're juggling school, and I understand that you have priorities outside of my class. So that's the minimum I ask for. But if you challenge yourself, you will benefit. That's my answer to that question. Viomini, one paragraph. That does not apply to you because you're new. Okay. And if number one I think number one is going to be too hard for you, Viomini. I think number two would be easier to explain. And I think number two is more interesting, don't y'all? Just the nuclear power plant stories. They're fascinating, yes. Yeah. Just really quickly, you know, we have over almost 500 nuclear power plants worldwide right now. Did y'all know that? Okay. So, I mean, right. Let's build more. Yeah. All right. Next Saturday, I will do proponents. So Viomini, I'll see you next Saturday for proponents for the other side, because I know you have two classes. And then that ends this class and that ends this recording. Are we good? Thank you. Thank you for coming. Glad y'all could do the options. All right. Have a great week, everybody.